Rutkowska, the owner of, what company is she at? I've forgotten now, but she introduced a technique called Blue Pill, the first open source rootkit. Now that has tremendous significance. If you're not into security, rootkits are very insidious software programs, stealth programs, that live down in the lowest areas of the computer, the kernel, and they are able to go in and pretty silently, pretty stealthily monitor actions, change the system around, ultimately to steal information, typically to steal personal information, credential information, or to provide different kinds of attacks, denial of service attacks. So rootkit detection is probably, if you recall that sequence of security threats and security solutions, rootkits was one of the more modern ones that we have today that's been most recently deployed by us vendors. But they're tough to find. Rootkit detection, again, through the techniques of either in context or out of context virtualization monitoring by means of virtualization, can be similarly stealthily detected to the benefit of us, computer users. The immutable, unchangeable systems monitoring is another area where, again, if you're stealth and if you're off to the side, or if you're in a self-contained in-context module within the guest operating system, you're able to look outside and do the same kind of monitoring that we do today, same kind of security software for what we call HIPS, host intrusion protection software, that vendors supply today, but do that from a protected environment. Monitoring of memory, as I've been describing, intra-API monitoring, and plumb lining. Plumb lining, again, is a way of following the call sequences for your APIs that go down and access the kernel to the lower levels in order to affect the given function that needs to be done. And again, if that call sequence, that plumb lining, is able to find or discovers that the typical scenarios are being followed, you'll be okay. But if not, that's when the flag is raised, and again, the security software will be able to flag the system, you, the user, the management system, or otherwise just note that there is some problem. Execution profiling. These are all different technical approaches that are enhanceable today. Watching the elevation of execution priorities, watching for changes in the registry stack and some of the execution stacks down below that normally aren't touched, but if those are changed, those are the things that are able to affect the way that the applications work. That is, if malware is in gear. Patch guard bypassing. Not a good word, but the point is that if there is some mechanism down below, patch guard is that kernel patch protection mechanism that Vista 64 uses to protect the kernel. And if the technique that I'll just state the technique and you can draw your conclusion. The technique that's used is if patch guard determines that there is somebody accessing and modifying registers, putting hooks in, API hooks in to determine calling sequences and to be injecting potentially malware processes into normal calls, the KPP or the patch guard system blue screens the system because it detected what can be only to be determined as malware in the system. So that's not an overly elegant way of protecting the system, and as I said, that's different from the way that we security vendors protect software systems today. The fourth pillar is that of scalable security management. I cannot emphasize enough the importance, the value, the benefit that is able to be brought about through the use of a well-constructed, well-designed, extensible security management system. You can think of it as a hub of the wheel. The security management system is able to provision all of the endpoints, all of your routers, your switches, your endpoint computers with the proper policies, with the proper security software to make sure that it is compliant with your corporate guidelines. Ultimately, I alluded a bit to this before, but I give this a separate section because we can use VMs within a security system, as shown here, to and truly make it a hierarchical, cluster-based, redundant, and scalable management system. Throughout the architecture of that management, it would access down to various layers within the system as it provisioned that policy out to different areas, and even the subservient server nodes would be outfitted with the VMs for immediate scalability and backup in the event that there are problems of a certain type or a certain type of protection is necessary. All of this leads to really where enterprises are at today as far as the security life cycle. Risk management is the basis is at the root of all security IT people's modus operandi. Whether they know it or not, they are really managing 4 quadrants that we've depicted here that can simply be described as find what's on your network today, figure out how many assets, what kind of assets that you have in your network, figure out what vintage they are, what the vulnerabilities are. There are tools that can be run to determine where the vulnerabilities, security vulnerabilities are, and then to evaluate those vulnerabilities relative to your specific corporate needs, deploy and enforce, deploy protection software and hardware in order to really protect that system that your enterprise is running on, and receive back information about its operation, its exceptions, if there are problems, and then deal with those through a fix and comply area. So patches would be deployed on systems that are deemed to be either out of compliance or out of date or attacked and compromised. So again, that cycle of life, or cycle of security life, is really typical. There is no beginning, there is no end, but ultimately this is the sequence that is followed in a typical day of an IT manager's life. So layering on top of this, Foundstone is one of the tools that McAfee provides that provides some of that vulnerability scanning. Could be living and is indeed going to soon be living in virtual machines that are sitting at various points within the system, able to be instantiated on a moment's notice based on the kind of vulnerability that might be demonstrated or known to be existing or determined through other mechanisms. Some very specific targeted scans and proper specifically provisioned VMs would be spun up and put into gears. Same too for asset discovery and visualization of the network resources. Again, the VM sitting outside is that external context, that out of context monitoring that I described. A sentinel is often described too as a sentinel that's able to watch over the overall system. Again, through using the memory modeling techniques, through special interfaces that do exist right now that are being enhanced at the hypervisor layer with the various manufacturers and APIs that would allow us security players, to go down and with proper authentication to ensure that it's a security player, go down into the system and have some visibility to the goings-on of the kernel mechanism, if you will, or the lower level parts of the system. Again, having a greater visibility to how the system is operating. Is it operating atypically, which would be an indication that there is malware present in that system. And VMs operating inside the system, that boundary inside the virtual machine target itself, virtual machine or components that live within the VM that perform taste testing. Remember the days of old, we used to have the kings and would have a pigeon or some unlucky court jester who would first taste the food, and if the pigeon didn't keel over, or if the jester didn't fall over dead, the king can go on and finish eating his food. Well, that same kind of taste testing is an interesting technique that's in play, that's in development right now in an automated manner. In other words, if a virtual machine that's spun up inside a questionable system is able to survive, and it's not being detected as having been attacked by some malware, then it can give a thumbs up to the rest of the system saying, okay, this system is currently